Hi, I'm Dick W4ETO. This is W4ETO, and this is ETO's new Alpha 87A microprocessor controlled linear amplifier. As advertised, this is a strictly informal home video, not at all slick, unrehearsed, unscripted. The whole idea is to give you all the information we can about the workings of the 87A. I want you to know, to understand why I say nothing else is even close to an Alpha 87A. Why hundreds of new 87A owners not only love their amplifier, they describe it with words like amazing, incredible, fantastic. Stick around, let me see if I can convince you why that is. 1, 2, 3, 4 test, hello test, W4ETO. Hello test, 1, 2, 3, 4, this is W4ETO testing. Hello test, 1, 2, 3, 4, this is W4ETO testing. 1, 2, 3, 4 test, hello test, 1, 2, 3, 4. Why is the 87A so popular? Just point out two things before we zero in closer so you can read this panel better. This row of buttons indicates the band on which the 87A is operating. 160 meters, 80 meters, on over through 15, 12, and 10 meters. This is the RF output watt meter, 2.5 kilowatts full scale, 1.5 kilowatt level right here. In the previous brief demonstration, I was simply switching bands on the transceiver and talking. And if you watch closely this time, you can see what was happening. 1, 2, 3, 4, that's 15 meters, 1, 2, 3, 4. Hello test, 1. Hello test, 1, 2, 3, 4. That's 7 megacycles, 40 meters. 1, 2, 3, 4 test, hello test, that's 160 meters. Hello test, 1, 2, 3, 4 from W4ETO, that's 10 meters. Maximum legal power on all the bands from 1.8 through 28 megs, 29.7 actually, with fully automatic band changing, never taking more than 1 second, often as little as a half a second or a quarter of a second to change bands, and the ability to match your antenna perfectly. No other amplifier can do it. There's nothing even close to an 87A. Let's take a closer look at the monitoring section of the 87A front panel, or the metering section. And I apologize that this 8mm home video equipment blurs the legends because of the severe contrast between the white letters and the black panel. To the eye, it's very sharp. Here at the top, we have the RF output watt meter, the 1.5 kilowatt full scale point up to which the bar graph is green, and the overshoot area, which goes to a total of about 2.5 kilowatts at full scale. Grid current, normal range of grid current is in the center here, anywhere from 20 or 30 mils up to perhaps 70 or 80 mils, depending on power level of operation. Anything above 105 mils corresponds to flat topping, distortion, possible tube damage, and is thoroughly protected by integral circuitry in the 87A. This is a continuous indication of reflected power from the load. There is a SWR protection built into the 87A, which trips when the reflected power exceeds approximately 200-250 watts up in this range. 150 watts corresponds to approximately to a 2-to-1 SWR at 1500 watts maximum legal power output. The multimeter bar graph down here has three functions selected by the push buttons to its right. A tune-up meter function to help in manual tuning of the amplifier, manual programming, plate current or IP, just a matter of interest, and high voltage. The scale for the tune meter is uncalibrated except for the normal range in the center here shown by this bracket. Plate current is read on the bottom scale, 0 to 1.5 amps full scale, high voltage on the top scale, 0 to 3 kV full scale. Below the metering, we have status indicator lamps, operate, indicating that the amplifier is fully warmed up and in the operate condition, standby, which may indicate either that there has been a so-called soft fault in which the amplifier trips to standby or bypass to protect itself, and I've just manually switched to standby to illustrate. A wait LED, which is illuminated during warm-up and during the very brief interval when the amplifier is changing bands. Fault LED, which indicates that a fault has occurred, and then specific indicators for a plate fault and a transmit-receive system sequencing fault, which we'll touch on later. Below these are the four switches that simply control power on-off, the operate standby, and a high-low power position. They're just out of the picture. Now let's take a look at the left side of the panel. These controls and indicators normally will never be used during operation. They're for programming. The push buttons are for programming the amplifier to what we might call fine-tune it precisely to your antenna and your operating habits. Each of the buttons has an LED to indicate when that button is activated. You should be able to read at this point the labels on the band buttons across the top row, 1.8 megs on the left, 3.5, 7, so forth, over to 28 megahertz, which is selected at the moment. The second row of 5 buttons serves multiple purposes. One is that it selects or indicates which segment of each band. Each band is divided into 100 kilohertz increments for tuning purposes, with the exception of 160 meters and 10 meters, which are divided respectively into 40 kilohertz and 400 kilohertz increments. A close study of the legends below the segment buttons show that the 160 meter band is divided into segments 1.8 to 1.84, 1.84 to 1.88, and so forth up to 2 megs. 10 meters is divided 28.0 to 28.4, 28.4 to 28.8, and so forth. These buttons are also used for several other purposes, as we'll explain later on. The band buttons primarily for programming of the automatic antenna selector switch, or digital antenna selector, that is also offered as a companion unit for the Alpha 87A. The segment buttons primarily are used as an indicator of faults. That is, when a fault occurs, let's just say that you accidentally hit your Alpha 87A with 200 watts of drive. The amplifier soft faults, that is, it switches to standby and bypasses the power to the antenna or to the load. And one or more of the LEDs on the segment buttons will light up and flash, giving a binary code that can be translated through a chart in the instruction manual to tell you just what caused that fault. On the bottom row are some buttons that are probably more self-evident as to their function. The default button is used to recall factory programming at any time when the amplifier has been retuned, fine-tuned in the field to suit the operator, and for some reason he wants to return to the factory programming, maybe just as a starting point. Pushing the default button accomplishes that. The tune up and tune down buttons correspond exactly to a knob, to a plate tuning knob on a conventional amplifier, and are used to rotate the tuning capacitor, except that it's done electronically, one step, 1 degree at a time. 2 degrees at a time, I'm sorry. The load buttons likewise rotate the loading capacitor in the plate circuit for the purpose of manual adjustment. And the enter button is used for several purposes: for memorizing tuning adjustments, for programming the antenna selection, and when used with a digital antenna selector, and so forth.